Today we are going to work out another example of a situation that is modeled by quadratic functions, and I'll ask a few questions and see if we can get some answers. Whenever we give you a problem where you would have to solve for either the independence or the dependence variable, we don't even have to ask you, but you should always find the function that models the situation. In our case, I'm going to ask you specifically, but even if we don't, you should always find a function first, because without the function, you couldn't answer questions related to your variables x and y. So let's just assume we launched an object from the ground, and this object reaches a maximum height of 180 feet after 3 seconds. I could immediately, right after this period, I could say, when will the object reach a maximum height of 60 feet? At time equals 5 seconds, where is the object? I can ask all sorts of questions. And if that happens, you should always begin with this question. Even if it is not explicitly asked of you, you've got to find a function. So I wrote down both forms of the quadratic functions. We have two forms. There is another one called the two roots forms. It's not that important. So here is your ax squared plus bx plus c. Obviously, our x here is time t, and my y here is the height of the object at time t. So this is like your y, and t is like your x. So this is the standard form, and this is the vertex form. And I put the three parameters that we would need to find if we choose to use this model. My three parameters are h, k, and little a. Remember, t is your variable, and h of t is your other variable. Okay, so we're not looking for those. We're looking for the actual constants. We call them parameters because we don't know their values yet, so we call them parameters. So these are the three parameters I would need to find. If we choose to use this form, then I would have to find three different parameters, a, b, and c. Remember, t is your x and h of t is your y. So the question becomes, what model would you use? Well, you obviously want to leverage your time and figure out what is given to you. They gave me a maximum height after 3 seconds. So they basically gave me a point called 3, 180, not 180, 3, okay? Because time comes first. Time is independent, and the height of the object is the dependent variable on the time. Not only that, it's not just a point there. They gave me actually the vertex, didn't they? They say it reaches a maximum of 180 feet after 3 seconds. So I was given the vertex. I was also given a point because it says an object is launched from the ground. That means when time equals 0, the height equals 0. So this is time, this is the height. Okay, so they gave me an extra points. And when I look at these 2 points that they gave me, if I want to use this form, clearly the y-intercept is given. So this 0 here is exactly that 0, right? It's a height. It's not in seconds, but it is in feet. So they gave me c. They did not give me a or b. When I look at this model, they gave me h and k because hk is your vertex. hk, h, not negative h, but h comma k is your vertex. So they gave me the vertex 3, 180. Okay, so h is 3 seconds and k is 180 feet. And they did not give me a. So obviously, it makes perfect sense to use this model because I know 2 out of 3 parameters. But in here, I could still do it, by the way, but it'll take me a long time. I'm only given 1 parameter out of 3. Okay, so clearly I am going to use this form. Now, before I proceed, let me just remind you that that a here is exactly that a here. So if you know this a, you obviously know that a. Those two a's are identical. Okay, so how do we proceed? Well, I plugged in what's given to me. We know h, we know k, and I'm going to try to find a, right? So if I plug in my h, in my k, it looks like the only thing I need to find is a. Well, I was given a point. So I could let x or t be 0 and y or h of t be 0 as well to find a. And that is exactly what I did here. I guess I just wrote it twice. Oh, you know what? I should have written my actual function. Minus h t minus, excuse me. I meant to write my actual function before I plug in. So this is my general form, right? And now what I did here is I plugged in h and I plugged in k, and I need to find a, but I'm going to use this point. Momentarily, we're going to force h of t to be 0, and we're going to force t to be 0 just for a split second, just so I can find a. So I have 0 minus 3 squared plus 180 times a equals 0. Now, of course, exponent comes first, so this is 0 minus 3, which is negative 3. Negative 3 quantity squared is 9, so we have 9a plus 180 equals 0. 9a plus 180 equals 0. Subtract 180, divide by 9, I got negative 20. Therefore, my function now, my model, I know h, I know k, I know a. I plug them in. Here they are. H is 3, k is 180 feet, and a is negative 20. Now, I wrote h of t and t in blue just to remind you that those are your variables, okay? So I found the model. This is the machine. This is the thing that's going to help me every single time. You have to be able to find all three, okay? I was given 2. It wasn't hard to find a using this points, and here is my model. So now you could ask me any question you want, right? And we should be able to solve. Notice something before I proceed. We knew that the object reaches a maximum height. So we knew that the parabola is going to face down, right? Because that's the only way you can get a maximum height. If it is facing up, you have a minimum. So that makes no sense. Because we know that the parabola is concave down, we already know that A has to be, finish the sentence, negative, right? And we found that A was negative 20. So if for whatever reason you did the math and you're rushed and you said A equals 20, that should trigger in your head that you made a mistake, because A is expected to be a negative number. Make sense? All right, so I'm going to use my model. Here it is, and I'm going to ask a couple of questions. First question, when will the objects return to the ground? I translate this as, please find x when y is given. When you return to the ground, that means the height is 0. That's your y, right? So the height is 0, and I'm looking for x. It's always one or the other. We give you this, we ask for this, or we give you this and we ask for that. These are your x and y's, okay? We give you one and we ask for the other. It's no big deal. I'm going to show you 2 ways for this particular situation. The first way is just to let h of t be 0, right? So this h of t has to be 0, right? And I'm going to solve for t. So let's take it from here. This is my model. I replace h of t by 0, and now I'm going to solve. Now, we're trying to isolate t, right? We're trying to isolate t. You cannot move the 3. It's trapped in the parentheses, and it is trapped under a square. You cannot move the negative 20 so fast. It is attached, being multiplied. It is attached to this quantity. That is the first term to go. That is the very first term to go. If you move it here, it becomes negative 180. And then when you divide by negative 20, because it is multiplication, you get 9. Okay? So you move this one first, then you move this one second, and that should give you 9. And that remains here. Got it? Okay? Now, I cannot move the 3 yet because I have a square. So I'm going to apply the square root on both sides of the equation in black. So I literally rewrote the equation in black, and I applied square roots. Now, square root of 9 is exactly 3. Please don't say plus or minus 3, okay? Square root of 9 is 3. However, square root of some quantity, let's call this x. Square root of x squared is plus or minus x. Square root of x squared is plus or minus x. Remember, x happens to be t minus 3, okay? So the answer is plus or minus, in parentheses, t minus 3 equals 3, okay? So over here, now what do I do next? I'm trying to isolate t. Don't move the 3 yet. Let's transfer this plus or minus to the right-hand side. Okay, so if I move this plus or minus to this side, it looks exactly like this. And as I mentioned before, a lot of kids think that square root of 9 is plus or minus 3. It's not true. Square root of 9 is exactly 3. The plus or minus actually came from the left-hand side. It did not come from here. So don't make this mistake, okay? And then the last thing I'm going to do is add 3. So here is my plus or minus 3, and I'm going to add 3. So I have two solutions. Plus 3, which is 6. Negative 3 plus 3, which is 0. Now we expected one of them to be 0 because the object was launched from the ground. Basically, the parabola, we knew that the parabola started here and reached some maximum and headed back. And I want to know, when does it return to the ground? We already knew that one of the times is going to be 0 because that's where it was launched. Now, if I had started here, you wouldn't know this. You wouldn't know this ahead of time until you finish, right? We knew t equals 0 is one of the answers, but pay attention to the question. I didn't say find a time when the object is on the ground. I said find a time when the object returns. I should have said S, sorry. It's gonna bother me. Give me a second. There you go. Okay, when will the object, no, I was right. When will the object return to the ground? Okay, sorry. Okay, so we knew it's going to return to the ground after 6 seconds. There is another method that will allow me to actually avoid all of this, but just for this particular example. Because this object was launched from the ground, t equals 0. I'm only looking at the x value. And we know this is 3 because the maximum is 3180. We obviously knew this is going to be 6. Makes sense? So if this is given to you on a test, you could actually take advantage of the fact that you started at the origin. You knew h, k. You knew that h is 3. That distance has to be duplicated, and therefore you expect the answer to be 6, right? And that's why we got 0 and 6. Well, be careful. If the question is like this, you hit, the object was launched from 5 feet high, and I say, where would it return to the ground? You wouldn't know the answer until you do all this math, right? You wouldn't even know this number here. This negative t, you wouldn't know that. You wouldn't know that t until you solve for t. Now, some students might say, why do I have to use this method? I mean, let's say you're here or here. Can I FOIL this? Can I call this t squared minus 6t plus 9, multiply that by negative 20, add 180, get a quadratic formula, get a quadratic equation that looks like this, okay, and then use the quadratic formula? You can, but you're wasting so much time. Why? Because a perfect square is given to you. All you have to do is isolate this perfect square so you can apply the square root in blue. So when a perfect square is given to you, it's not a good idea to distribute. You are allowed to, but you're going to waste a lot of time, okay? Why would you want to distribute and then factor at the end when you already have a nice, beautiful, perfect square, okay? So I would suggest this is probably the best way to go about this problem. So let's go on to another question. At what time, I'm asking for time now, see, time was given. Actually, I'm asking a similar question. For what time will the height reach a height of 200 feet? Some of you with clever answers would say, well, my maximum height was 180. clearly I am not going to reach 200 feet. Makes sense? Therefore, there is no time. There is no such thing as a time for which the height of the object is 200. If you didn't see that, no problem. You start with your model. Here is your A, here is your H, here is your K, here is your X, here is your Y. And plug in 200 for height, just like I plugged in 0 for the height, okay? I ask you this question for a different reason. Subtract the 180 first. Please don't divide by negative 20. You've got to subtract this guy first, which gives me 20. Divide by negative 20, you get negative 1. Do you see that there is a problem here? This is a perfect square, right? And a perfect square, like x squared, a perfect square is always greater or equal to 0. Isn't that true? So t minus 3 quantity squared is definitely greater or equal to 0. However, the right-hand side is negative. Isn't that true? This guy is negative. This is greater or equal to 0. Impossible. Contradiction. This is in case you didn't see that the maximum height was 180, and therefore you can't reach 200. You could still do the math. It takes, 10, 15 seconds, and you're going to get into a contradiction. One of you might say, well, what if I don't see the contradiction? Well, if you don't see the contradiction, you're going to take square root, right? So you have t minus 3 squared equals negative 1. And I hope now you'll see the contradiction. You cannot take a square root of a negative number. I mean, you can, but we're not working with non-real numbers. Right now, all we know are real numbers. We don't know complex numbers, okay? Another one might say, well, what if I don't apply square root? What if I want to take the longest way? Okay, well, let's take the longest way. Let's be silly and distribute. You get t squared minus 6t plus 9 equals negative 1. So that means t squared minus 6t plus 8 equals 0. And we can use the quadratic formula. And guess what? I guarantee you that the discriminant is going to be negative. You're not going to get solutions. What is the discriminant? It's b squared minus 4ac. Isn't that true? So it's b squared. Notice the squared is outside of the parentheses. Minus 4ac. This is a. This is b. And this is c. Okay? Do you see that this is 36 and this is negative 32? Oh, I made a mistake, right? T squared minus 6t plus 9 equals negative 1. Oh yeah, here is a mistake. Of course I made a mistake because I'm expected to get a negative discriminant. This is 10, right? When you add this one here, it becomes 10. So b squared, here it is, minus 4ac. C is 10. And therefore, this is negative 40. And therefore, the discriminant is negative 4, which is negative. That tells me there is no solution. Makes sense? I really hope you don't distribute. You just end up wasting so much time. Okay? So let me erase this. Okay, good. I'm going to end with one more question quickly. And that is, I have given you h of t, and I ask you to find t twice. Actually, when we give you t, it's easy to find h of t. I should have begun with this question. So what is the height of the object after 2 seconds? In other words, when t is 2 seconds, what's the height? You can combine both of these into this question, right? What is h of 2? H of 2 means when time is 2 seconds, what's h of t, right? Well, that's easy. Here is my model again. I always begin with my model. I spent 10 minutes figuring out my model. You should always start with your model before you plug in anything, okay? So here is my model. I plugged in 2 for t. So just plug in 2 here. And just respect the order of operation. 2 minus 3 is negative 1. Negative 1 squared is 1. 1 times negative 20 is negative 20 plus 180. Right? And that's 160 feet. Done. So actually, if I give you time and I ask for h of t, it is always the easiest. When we give you x and we ask you to solve for y. But when we give you y and ask you to solve for x, like I did here or here, it's a little longer. Let me just conclude with a quick picture. If I say graph it, well, you know it starts at the origin. You know it hits a maximum of 180. That was given to you, so you already knew this half. You can easily find the image of 0, 0, which is 6, 0, and here's the other half. Or, since you did this, you know, when the height is 0, time was 6. So here's the image of this guy. Here is your maximum. It's over, done. Notice there is no second quadrant, no third quadrant, no fourth quadrant. Notice I label my x-axis to be t in seconds. I should say in seconds, right? In seconds. And the height is in feet, okay? And I just wrote this stuff here in red for you. So after 2 seconds, you were at 160 feet. And I asked you earlier, what time will you hit a height of 200? Well, 200 is above 180. That's not going to happen, right? Now, the reason I did this, I'm sure you could see the point, right? 160, right? 2 seconds, 160. It has to be lower than 180. Please don't make this mistake. Don't say, since it took 3 seconds to travel 180 feet, let me do it here in green. Here is 3 seconds. This is time. 1 second, 2 seconds, 3 seconds. To travel a height of 180, 3 seconds for 180 feet, don't say, oh, therefore for 2 seconds I would have traveled 120 feet, right? And for 1 second I would have traveled 60 feet. As if you're supposed to travel 60 feet each second, right? If it takes you 3 seconds to travel 180, you might think that after 2 seconds, you would have traveled 120. We know the answer is wrong, right? The answer is actually 160. Why aren't you allowed to do this stuff in green? Pause the video and think about it. Why aren't you allowed to use this stuff in green? Say, oh, that's easy. After 2 seconds, it has to be 120. After 1 second, it has to be 60, right? It is because the function is not linear. So you can't scale the same way, okay? So the function is not linear, so you really have to do the work. And you know the answer is 160, not 120, okay? So be careful with that one. I think I'm gonna stop it here. I think this is plenty. I hope this was helpful, and we will continue the conversation later.